All right, as usual, let's see what's important for you to notice at the moment. Let's see some reminders. I think quite a few for this week. So your lab number 1 has been released. It's going to be the same formats for lab number 1 all the way to lab number 5, and also for your programming test number 1, 2, and 3, all the same format. So this will be your best opportunity to really get used to the format. And your markup programming test is going to be this Friday, either 5 or 6 p.m. If you haven't really registered yet, please check my e-class announcements sent out on Friday and make sure you register. We may have some limited space left. Please, first come, first serve. But of course, if you really want to take it, I should get some seat for you, but register first. And your written test number 1 is coming next Wednesday during the scheduled lab session. If you check your course calendar, I will make sure I give you some detailed guides about what you can expect and some example questions for you to try. We can potentially schedule maybe some optional review session to go over your questions. We can do that. But let me get to you a little bit later. Okay? But written test number 1. But at the same time, programming test 1 is also going to happen just a week after. So I think your best way to get prepared for programming test 1, try to treat this one as if it's the actual test. Get as much prep done as possible for yourself. And once you have taken the the markup programming test, you will kind of realize what kind of improvement you can really make in the coming week or so. That will be really the value for markup test. And, there's something just administrative I just want to remind you, which I sent last night. In case you haven't seen that, if you go to the course lecture site, there underneath the syllabus, over here. I'll show you. Sorry. Yeah, exactly. Sorry. If you see underneath the syllabus, I'll make it bigger. Underneath the course syllabus, there is, maybe I need to refresh my browser. There we go. There's a document there, I click on class attendance rules. And nothing should be surprising. That's basically based on how we did the experiments on that week. I just write them down. So just to get you some reminder. I think the most important thing is if your iClicker didn't actually work when we did experiments, you may want to consult with this particular link, which is official guide about how you can refresh your location. Okay? And please read over the procedure. That's something I'm going to follow for all your attendance checks. Now that the enrollment gets a little bit more stabilized, we can do more checks and hopefully give you guys bonus. That's really the intention. Okay, let's now have a very quick recap about what we talked about last time. And then we'll talk about some last bit of the discussion about static variables to finish off the review. All right, let's quick recap. So we talk about the use of anonymous objects is a very practical way to simplify your code, and sometimes you might find it very handy to use anonymous objects together with helper method. You can review the notes to see how you might do that. You might find lots of places you can use these two or a combination of these two in your subsequent labs. So just use them. The more you use them, the more confident you might be about using them. And then we talk about the entire exercise of this marriage example over here. Right? I'm not going to repeat the details, but you should really try to see every detail I talk about over there. And specifically, we'll talk about the logical operator. Right? You may want to review them too. They will be covered as well in your written test number 1. So go over the example, and there was some exercise assigned to you, which should be quite straightforward to really get right. You can feel free to test it. If you want to discuss your answer with me, I'm more than happy to. Just reach out. Otherwise, you assume you are okay. All right, and then we started talking about the motivation for using static variables in Java and for any OOP. So here we talk about if in the constructor for the account class, we have to explicitly add a single parameter for managing the ID. So that means the user of the account class have to pass explicitly some IDs and make sure they are not duplicated. It's not the way to go. It's manual, it's error prone. That's not the way to go. And what we said was we were kind of preparing you for the ultimate solution for this, which would be to use the static variables. That's why we didn't really see the actual solution just yet last time, but we want to refresh your memory about the static variable. Right? So you want to be very clear on this particular example. So we got either non-static because in this declaration here, you don't see any static keyword versus static variable. Right? We'll talk about what will be the consequence after declaring non-static versus static. You should really go over this example here, and the code source is all available on the lecture site. Play with them, extend it in whatever way you like, and try to see if you're convinced on the way static variables work. All right. Any questions from last time? Any part you want me to repeat or clarify? Now would be the time before I move on. We're good? Alrighty. So the final bit for this review will be to discuss some, number one, application of the static variables, which will be very practical, how we can manage user IDs automatically. And then number two, we want to see some consequence of using static variables inappropriately. That's something we'd like to study as well. One thing at a time. All right, let's now go back to the slide. You should now be looking at slide number 76, in case you're looking at that. So this will be the solution for managing the account ID. Can be account ID, member ID, student ID. Every time you want to manage certain counter internal to the class automatically, you should think about this global static variable. That will be the general tip for you. And let's now go over this solution here, and then it's not difficult. You just have to, assuming that you already understood about how static variables used in general versus non-static, this solution here should be no surprise to you. Let's take a look. Let's now go to here. Let's now go over them. Number one, you can see that we got internal, which means private counter over here, right? Internal. And then it is static, meaning that it's going to be shared by all the instances of type account. Right? As soon as you see static, you know that it's a single copy that's going to be shared by all the instances of the same class. And a global counter, and this will be the initialization for the global variable. Initialization. That means you can set aside some box right away over here, and that's going to be a single copy for account. And it's called global counter. I'll just GC for now, all right? And if you want, you can just put a star over here, just tell yourself it's actually static. Okay, it's not non-static. And the initial value will just be 1. All good. And we also got the ordinary non-static variable. We got ID and we got owner. So what I want you to compare and contrast will be the global counter over here and the ID over here. Because the ID over here is non-static, you don't see any static keyword over here. So you can just make a note to yourself over here. This tells you the ID here is local. Each object of type account has its own copy. Right? That's also something we said already, right? About the difference between the two, right? I'm just trying to remind you. And one very important comparison to make right away. Take a look at the constructor over here. Account, okay? This is version number 2, the ultimate version. Versus last time when we talked about the account over here. All right? Let me do it again. This is what we said, the bad version. 1 parameter, 2 parameters. You can see ID is part of the input list, if you want to call the constructor. But as soon as we have introduced the static counter internally, we don't need that anymore. You can see here, we don't have ID. That's something you want to notice right away. Okay? I'll make a note here. So here, the parameter list does not include the ID. The parameter not including the ID. It's a very important thing to notice. As soon as you start using the automatic counter using static, that's the good consequence of that, right? And inside the constructor, what you have to do is very standard. Over here. Oh, let me do a little bit better. 3 lines of code. But you know what? Only 2 lines. These are the 2 lines I want you to pay attention to. Okay, very important. Okay, and the third line over here is just assigning the owner to the owner. That was no surprise, right? Nothing to do with static. But here you can see that what we have over here. We say that the local copy of the ID of this, the context object, the object we're creating right now, we're going to assign its own copy of ID into the same value as a local counter, sorry, as a global counter, which is 1 at the moment, for example. And then the global counter might be updated to 2 or 3 or later, right? You have to make sure every time you have to update the global counter once you have used it for once. Okay? And we're going to see how this works. But if you can already somehow imagine yourself how creating multiple account objects is going to update this global counter automatically, then you understand what the magic is. Okay? Let's now trace the code very quickly, right? And understanding this can also help us understand some common errors that we might run into in the programming. Okay? That's something we'll get into a little bit later. Let's try. So let's try this line over here, right? This line here, ACC1, ACC1, pointing to an account object over here. Every account has how many attributes? You can see we only include non-static attributes in the box. So only the ID and the owner. So we got ID and we got owner over here. Right? Let me just copy that so I don't need to draw again. All right, so the owner will be easy because now we're passing Jin, right? So owner will just be pointing to some string objects for Jin. That one's easy. What about the ID? When we step into the account constructor over here, let's say step into this. All right, we say this.id. What's this? This is basically the ACC1 that we're talking about over here, right? We're saying ACC1.id, which is referring to this slot over here. It's going to copy the value for global counter as is right now, which is number 1. Right? We're going to put 1 over here. And don't forget, it will be an error if you forgot to have this line. Because if you forgot about this line, what's going to happen? Every account object is going to have ID 1, which is totally wrong. It's a logical error you want to avoid. So now the second line to really execute will be global counter should be ++. From 1 to 2. So this will be the entire process now for creating a single account object. Let's see one more, and the pattern will just go on. Will just go on. All right, the second one here, this line. Let's do it again, just to make sure you totally understand. So this line here, so ACC2 is pointing to just another account objects. And then I should have purple here. That's good. And then we're going to, for the owner, it's going to be Jeremy this time, right? Owner is going to be Jeremy. What about ID? And we're going to step into the account constructor once more for the second time. All right, execute this one second time. This.id is now referring to ACC2.id, which will be this particular slot. And then it should be the current value for global counter, which is no longer 1. It's now 2, right? 2 over here. And then don't forget, you got to update this counter so that if you try to create a third object, you're going to have the 3, and so on. So how can you kind of study this kind of a problem over here to think about what question I might ask you in the written test or the exam? You can say, okay, given that this is the correct implementation, what's going to happen? For example, if I simply get rid of this line. Or what if I say I move this global counter ++ as the first line rather than the second line? What's going to be the consequence? Think about those kind of issues, right? You want to really dive into different variants of what I give to you as an example. Be a little bit more curious. Okay. Any question about this solution here? All right, I would say managing ID automatically this way is pretty standard. So once you understand the pattern, you don't really need to memorize it. Just understand the logic here. You need some global counter. You also need some local ID as well, and see how they interact with each other, right? Okay, if no question, let's move on. Question?
What if we put the ID static?
Say it again, sorry?
If we make the ID static.
If you make the ID static. The question was, what if, let's say, okay, I can put a question down. What if the ID is also static? Okay? It's definitely wrong. Because as soon as I see that ID is going to be static, that means all the account objects, they're going to share the same copy of the ID, meaning that they're going to have the same value for the ID. It's definitely wrong. And every time, let's say, if I got, let's say, 1 here and 1 here, let's say, for now, okay, they're the same ID because it's static. Let's say I want to create another object over here, the third one. If that one, their increment the counter, let's say, from 1 to 2, not only that it's going to get a number 2 ID, but also at the same time, they will be modified as well because they are kind of like a, sorry, let me say it again. Forget about what I just said. That's totally wrong. There's no aliasing here. Let me say it again. The ID here is integer, so it's a separate copy still. Okay. Let me just do that properly. If I cause any potential confusion, it's better to write it down. Let's now talk about this alternative solution. So we got the account class. Let's be very careful. And then let's say we got our, let's just say ID and global counter. Okay? We got static, integer, global counter. Let's say initially 1. Also, we got our static, integer, and then let's say that's also some ID. Okay? Only these two. And we have our constructor. Public account. Let's forget about owner just for now, just to make it a little bit simpler for us to focus. So we're going to do everything else the same. We're going to say ID is assigned to the global counter, and then we're going to say global counter plus plus. Let's say that, right? And see exactly what's going to happen. Okay, so there'll be absolutely no confusion. Let's now try to create, let's say, again, 2 account objects. So let's say we got account A1, new account. And then we got another one here. Let's say account, let me use a slightly different color here. How about this? Account A2. Let's say new account. Let's see what's going to happen over here. But first of all, we should realize it's wrong because it doesn't really comply with the pattern that we talk about. But let's see how wrong it is. Let's now, first of all, set aside the value for these two because they're both static. So the way you're going to visualize is like this. You're going to have over here a box for account. This time we got 2 static variables. We got global counter and also we got ID over here. Right? Both of them are static. There's only a single copy. All right? And don't really get confused with aliasing over here because they are still like a primitive type. It's just that they are static. So don't really get confused with aliasing, which I made a mistake about a few minutes ago. Okay? And then GC will be 1. All right? And here, let's say ID, we forgot to initialize it, which is okay. It will just get a default value, 0. All right? Let's say that's what we have. And let's now trace it. For this line over here, we're going to have A1, and then over here. And this will be a very peculiar box we're going to draw because at the moment, is there any non-static variable in the class? Not really, right? Because you can see both attributes here are both static. So we don't really put them at an instance-specific level, so nothing here. Right? That's one thing to notice. If we got owner, let's say, like before, you may put owner here. Okay? And then that's what we do. So at the moment, let's say if you say A1 dot ID, what's going to be the value? What's A1 dot ID? We are referring to the global counter here, right? Which is going to be 1. That's the number 1 check. All right? And then let's now try the second creation, right? That one there is actually going to create another object over here of type account. And again, the account class has no non-static attributes, so we don't put anything here. Still account. Now, what if I say A2.ID? What's going to be the value? 1? Agree? Because we are still referring to the 1 over here, the same. Also 1. Right? All good. And let's now see what's going to happen if I try to modify the value. So let me just put a sequence here. So this is the first check we did. That was the second check we did. Let's do a third check. Now, let's say somewhere I can try to do account. Remember I mentioned how you're supposed to refer to static variable, class name dot the variable name. If I say account dot ID, for example, ++. I do it somewhere. What's going to happen here? It's going to modify this copy here from 1 to 2. Now, if I try the third check, how about this? So think about this was step number 3. Now I do the check over here. What's going to be A1.ID? 1 or 2? What's 0? 2, right? Because it's really referring to this, oh, what am I doing? I'm changing the ID here, right? All right, you guys were too nice. You didn't correct me, right? Okay, maybe that's why you were confused. Let me, I just realized what I updated was just the global counter. I didn't update the ID. Okay, how about this? If you don't mind, let's wash them out. Let's do it again. Again, my apology. Okay, let's do it again. It's really important to get it right. Number 1, we set aside GC and ID. Account over here. And then we got GC, static. We got ID, also static. All right? And then we're going to get GC initially 1, ID initially 0. Okay, that's good. Okay, I'll be very careful here. And then let's now try to trace. Okay, be careful. All right, the first one here, we got A1, and we are trying to create an object over here. And again, there's no non-static variable, so we don't put anything here. So that will be account. Okay, and then we say ID over here is assigned to GC. So we just do the assignment. That's something I didn't say. That's why I made a mistake, right? Now it's right. And then we're going to increment the global counter by 1, 1 to 2. That should be the correct behavior, which I didn't do. Are we okay with this? Now it's correct. Okay. Any question about what I just did for the first object creation? Any question? Okay. And then after this, if you try the first check, number 1, if you say A1.ID, it should be 1. All right. Let's now create a second object. Let's say A2 is going to point to, again, an account object, no non-static. Here. And then Let's now execute this, right? ID is going to be GC. ID is going to be GC. Copy 2 over here. Okay? And then update the global counter by 1, incremented by 1. So from 2 to 3. Right? The same pattern. Now, second check. What's going to happen if you say A1.ID? What's that? Oh, sorry, A2.ID. That's what I meant. Let's ask that first. I'll ask you A1 for sure as well. What's A2.ID? 2. All right. Now, the most very important question here. What is A1.ID? What is that? Shouldn't that be 1? You say yes, but according to the diagram, ID is global, has been modified. It's 2. All right. This is really something I should have demonstrated to you 10 minutes ago. Again, my apology for the mistake, but now you got a correct explanation. Right? That's really what I meant. So you should really notice that if you actually put the ID itself also as static, the problem is whenever you're trying to modify the ID over here, it's going to modify for all the copies, for the single copy that's shared by all the instances. That's something you want to watch out for. That's why this is wrong. It's a very good question. Just took me a little bit longer to explain. Does it make sense to you? Okay. I think it's a wonderful question here because you really want to know the different kind of combination for the variables. And if you're curious enough, why don't you try different combination? What if both are non-static? What if this is non-static, but this is static? Try all the different combinations to convince yourself how they are supposed to work. All right? That'll be your exercise. All right, any question about this before I move on? We all good? Yeah, static variable is not that bad. You just have to know the principle and then be very patient to trace exactly how the code is going to work. That's really what it takes to get things right. All right, let's move on. Static variables. Yep, everything has been explained already. Okay, let's look at maybe a few errors, maybe 1 or 2 errors. 2 errors, I believe. The first one. Oh, that's interesting, huh? That's basically the kind of variance I would like you to consider right now. Let's say we got a client. Think about a client is like an account collector. So we got accounts array. And this integer counter, I even highlighted for you. If you go back to what you did in lab 0 part 2, and also the written notes, what we usually put there is not static. Agree? It's usually just private, integer, number of accounts, or number of members, whatever. But now I added static. All right? I can tell you that right away it's wrong because it's not complying with the pattern that we were learning. But how wrong is that? That's the thing. And we still got this add account method here. And the implementation here, I can tell these 2 lines are correct. That's basically just what we did. And what I want you guys to do is this. I'll just give you guys maybe a minute. This is what I just discussed about the programming pattern. The only change I introduced is this extra static keyword. Everything still compiles. It's still valid Java syntax, but I can already tell you it's wrong. And can you guys please, maybe you can either draw or you can just draw in your mind what's going to happen if I try to execute these lines of tester code. This tester code is going to demonstrate to you how wrong it is by changing that integer counter from non-static to static. Now, can you even try to imagine that yourself before I draw it out for you? 1 minute. Okay, think about it, right? If you really have no clue, that's okay. Just try to think to yourself, how am I going to, for example, create objects over here? That should be straightforward. How to create these two account objects should be straightforward. But now, what does it really mean when I got add account? And this method here is actually going to modify something static rather than something non-static, right? So what's the consequence of that? All right, maybe another 20 seconds or so. And then I'll see if anybody would like to share their thoughts. If no, I can just tell you the answer. Okay, 10 more seconds. All right, anybody would like to try? It's okay to be wrong. Robert.
This would be wrong because we want each person to have their own number of accounts.
Yep.
So when it's static, it's going to say, Bill and Steve, they have 2 accounts, right?
Okay, Bill and Steve, I agree. Definitely they got 2 separate arrays. Arrays themselves are non-static, so that's okay. But how is this, I agree, this static variable here, number of accounts, is going to be a single copy only. But how is that going to impact the ways that we store things into the 2 separate arrays?
It's because, so when we do bill.addAccount, and then that method call is going to increment the number of accounts, but that's static. So it will display that Bill has 2 accounts, but when in reality, it's both Steve and Bill's accounts.
Yeah, you're getting somewhere. Pretty much right. Okay? All right, let's now take a look. But if you're still thinking, that's okay. This one could be tricky. All right? Here's how it goes. Let's now create these objects first. Let's say these 2, Bill and Steve. Okay? So we got Bill over here is basically an account, clients, beg your pardon. Client, and then we got, by the way, so you can see the counter over here. There's going to be a separate, just a single copy of that. So we got number of accounts, right? I'll put a star here, it's static. Initially just 0, share copy. And then when I first create Bill, it has so this number of accounts should not belong to here, right? Because it's static. The only non-static attribute would be this particular attribute, that's non-static. So I'll say EECS accounts is an array, okay, something like that. 0, 1, for example. And then similarly, we also got that for Steve. Steve, we have Steve over here. Also an account, client objects. And then we got EECS. And then that one there is also going to point to an array of certain size, like that. Okay? And we also got, let's say we got ACC1, ACC2. Let's create 2 account objects. Let's say ACC1, some account object here. ACC2, some account object over here. And the contents for the account object, we don't care at this moment. Okay? Just 2 separate objects. And what we want to do is this. Bill.addAccount ACC1. The correct thing should be Bill.accounts at index 0 should be pointing to ACC1. And when we do Steve.addAccount ACC2, Steve accounts array also at index 0 should be pointing to account number 2. This should be what we expect to happen. But is it really the behavior that we're going to see at the runtime, given that this is static? Not anymore. Why? Let's take a look. When you execute this line here, Bill.addAccount, right? That one there, this first call is okay when you try to add ACC1. So you're just going to execute these 2 lines. Those 2 lines, I will just do the normal thing. Because at the moment, NOA is 0. So you're going to say at index 0 of the array is going to point to this particular ACC1. But when you get to this point, by incrementing the counter, incrementing from 0 to 1, now can you already see what the issue might be when we try to add a second account later? All right? Let's now try to do this. When we try to execute this line, Steve.addAccount ACC2. All right? At the moment, NOA is already 1, not 0 anymore, because this is a shared copy. So what's going to happen is we're going to execute, again, this method here, these two lines. Now, accounts at NOA, which will be index 1. So that means Steve accounts array at index 1 is now going to point to this one over here, right? And then when we do this increment over here, we're going to increment from 1 to 2. That means the next add account we're going to call on some objects is going to store index 2, and then index 3, index 4, right? It is only a shared copy for the counter. Apparently, you can see this space over here is wasted. That's something you want to convince yourself. So this one over here, wasted. That's wrong. All right, any question about this error here? I just changed the counter from non-static to static. That's what I did. Any question? Okay? If no more question, please study that and then really convince yourself. All right, next one. There's another one you might see sometimes in the Eclipse when you try to use the static variable in the wrong place. Let's take a look. Or use a non-static variable in the wrong place, either one. Right, so this page here, just slide here, just summarizes what I just illustrated to you. So you can also read it. It has been covered already. The final one to look at, all right? And I'll go over this code with you, okay? Let's say we have a class called bank. And we got non-static, non-static, and static. Right? So think about non-static, non-static, and we got static, and also static. The way you call a static method will be the same. Class name dot method name. For static variables, class name dot variable name, the same. Okay? And let's take a look. So we got every bank has its own branch name. Makes sense? And also, if you want to get a branch name, just return its branch name. And now we're saying that all the bank objects share an integer counter, just called the next account number, something like that. And then we have something called getInfo. And this is static. Okay? The fact that it is static, I can tell you something which you should realize yourself right away as well. What's the consequence? This means you can say bank dot get info. This will be the class name. And this will be the name of the static method. This is allowed in Java. As soon as you see static, that's what you want to think about, how you can use it right away. And inside this method here, we got two lines. Number one, we say we want to increment the counter, which was declared over here. And then we want to return some string, which is going to be a concatenation between the branch name and also the account number. All right? Anybody spotted an error here? There's something wrong here. Not really about tracing. Here, this example here, we don't need to do any tracing, but there's something wrong here.
So it's like the next account number is static. So instead of each account number being associated with its own branch, it's like a common account number.
Are you more referring to this one here? Okay, this one I can tell this is nothing wrong with this. This one here basically is saying this next account number is actually static. And the method here is also static. it is completely okay to refer to something that's static within some static method. It's fine. So nothing wrong with this. Maybe you're more thinking about like conceptually what should be done. Actually, even conceptually this is okay, because maybe our intention is to use this account number here as like a counter, like a global counter. So that's why we make it static, right? So I can tell you nothing wrong with this. So this part here is okay. How about point to you first? You next. Okay, you first.
So by calling bank and calling messenger, we cannot replace this keyword with bank. Because,
Are you talking about this one here? This one, just this alone over here. Okay, I see what you mean. You're basically on the right track, okay? So this part over here is wrong. Eclipse is going to complain. Okay, now we need to understand this. This part over here is going to trigger some compilation error. And the error message you will see, I really encourage you to try this on Eclipse as well. Non-static method or attributes cannot be referenced from a static context. You may have seen something like this in the first year. I'm not too sure. Maybe. If you haven't, that's okay. Now you see it. All right? That's exactly what's happening here. This guy here is non-static because we declare that to be non-static. You are referring to it inside this particular getInfo method, which is a context that's actually static. That's what the error message is saying. But why can you not do it? That's the question, right? That's something we want to understand a little bit deeper. The logic goes like this. And your classmate actually said it correctly about replacement, which is good, okay? Think about what's going to happen here. To call this static method. How do we call that? Well, as I said before, bank.getInfo. That's how we call that. And how do we replace this over here? Well, we said before, this will be something like a Jim.Mary or P1.getDistance from, like an object name. But now, can you use this bank over here to replace this? Not really. Okay? So now, subsequently, you're going to result in something like a bank.branch name. Right? I'm just replacing this over here by the bank. That's the best we could do, which is wrong. Because branch name itself is a non-static attribute. You cannot refer to a non-static attributes by using the class name. You must give some account, you must give some bank objects. Right? So this is wrong. So this one here is non-static. So what we have over here is wrong. Should be a context objects of type bank. Right? That's kind of the logic you want to think through about why you cannot refer to some non-static attributes inside a static method. All right? All right, any question about this? The reason is, when I write this one here, I was thinking that branch name is declared to be non-static. Agree? Just like all the attributes we talk about before we talk about static. So that's why you can always use some non-static attribute here to say this, to clarify, to say whatever context object you may call at the runtime, you're going to replace that context object for this. For example, let's say this. If I got, let's say, bank, CIBC will be new bank. Let's say. If I now say CIBC dot, let's say, branch name, this will be some normal usage we can expect, right? Because here you can see the context object CIBC is proper for this. However, now when we say get info, that one there is static, meaning that we will be able to refer to the static, we will be able to call the static method using the class name only. But if you do that, there's no context object like a CIBC over here for us to replace this. So there's a conflict over here. That's why there's an error. All right, that's a good question. So just allow me to make it even more explicit for everybody. All right, any more question about this? Yes. Say it again. If you try, are you saying when we just say this dot? You mean to make this, oh, that will be about the fix. Let me get there a little bit later. Good. So your classmate was talking about some fix, which I'll talk about 2 possible fixes. Okay. All right, number 1, understand why this will be an error. That's very important. And number 2, we got to think about what fixes we can get. Okay. And if you look at the slides, there are 2 possible fixes, right? So these are contradictory, right? That's something I just talked about. And there are 2 possible ways to fix it. All right, let me discuss them quickly. Let me just copy that to a new page. And let's talk about fixes. Okay, let's talk about fix number 1. Okay, let's see a slide. What does slide say? Basically, fix number 1, you just want to remove all the uses of the non-static variable from the method. Fix number 1. So I will just remove this one here. After removing this, you can see now as far as this method is concerned, it is static, and it's now calling static attributes only. So that's okay. That's fix number 1. Easy, you just remove something. Okay, so let me say fix number 1. And then I'll put in parallel about fix number 2. All right, let me make it a little bit smaller so I can put them side by side. Okay, fix number 1. And let's now talk about fix number 2, which basically also is trying to satisfy what the compiler wants. Compiler is saying you cannot refer to you can only refer to static variable in the static method. So why don't we make this one static, which is what you were thinking about. Okay, we'll get there and then we'll discuss it briefly. Fix number 2. Let's say we want to keep this guy here. Let's say we want to keep it. So what we can do instead is by adding static. That will also make the compiler happy. Because now in this consequent resulting code, in this static method here, we are referring to static variables only. So that's okay. But now, for fix number 2, is it appropriate though? Even though it might work programmatically, but what about design-wise? Is this a good idea though? What you want to ask yourself is this. By declaring this to be static, now you want to ask yourself, is there a shared branch name by all bank? Not really, right? There might be a branch around York. There might be a branch in Scarborough. There might be a branch in Newmarket. So if you make it static, you're saying all the banks will be the same branch. Doesn't make sense. So this is a typical example where things will work programmatically, but it doesn't make any design sense. You want to be careful. Okay? Okay. All right, I think that will be about all the reviews I would like to do for OOP. All right? Do you guys have any questions for me up to this point? Yes? Yes, I agree. Conceptually, you're right. let's say this one here, branch name, let's say it's static, right? By writing this, it's not going to trigger any compilation error. As I mentioned last time, it's going to give you some yellow underline, like a warning. Eclipse is going to warn you to say, wow, you're referring to some static variable using this. That doesn't sound right, but they wouldn't give you an error. Yeah, but whenever you want to refer to, let's say, static variable, you should always use the class name. You should. Yeah. All right, any more questions? Okay. Yeah, so if you go back to the slides, I believe that'll be the last one on the slides. And now you got at least a big chunk that you're supposed to study for written test number 1. So don't wait for me until tomorrow, but I would say from now, after the class, you can already start going over Lab 0, Part 1, Part 2, and also the review slides, the written notes for your written test number 1. And I would see, in some way, because we are slightly ahead of section E in the at 1 p.m., so that's okay. So I think I'm going to confirm about how many slides you should really study up to for the exception. Well, we can still cover some today and Thursday. What if I will finish covering? I will make the same slide to be the ending coverage for written test number 1. I'll confirm that. But for now, this for sure you got to study. Any question? Yes?
Can you explain why the main method also static always?
The reason is, you can think about that might be somehow relevant to what we're going to talk about when we talk about exceptions. The question was, why is the main method, oh, we don't have the main method here. I'll answer briefly. Normally, if you got some console application, right, you might say public, static, void, main, and then you might got something here. And let's say public class, let's say my class. Okay, let's say that's the layout. So the question was, why is this method over here static? It's because typically, if you actually want to call this particular main method here, this method here is supposed to be what we call the entry point of execution. Meaning that if you want to say right-click on this class and say run as Java application, the main method will be the starting point to execute lines of code. And the idea would be, if this will be the entry point of execution, we don't need to create any object to begin with. Just execute line by line. Maybe in some of those lines, you may have to create further objects, but not in the beginning. So here, that means you can simply call my class over here dot main. So this will be where the execution starts. And no object creation is necessary just yet. It's going to be just the very first method call you're going to make. So you don't want any context object, just the very first one for convenience. Yeah. All right, any other questions? Okay, let me pause the recording for now. And all right, so after we are done with the OOP review, let's now get to the first topic, the new topic maybe for many of you, which will be about exceptions. And hopefully within 2 classes or so, we'll see how much we can cover until end of Thursday. That will be the coverage for your written test number 1. And then after written test number 1, we'll talk about it. Okay, for now, let's just focus on learning the new stuff. Okay, and now let's look at what we're going to learn for this lecture here. Okay, guys, please. Thank you. All right, so what should we learn about in this module here, this lecture? So we're going to clarify something called caller versus callee. That's very important because think about exception is really like you have to analyze certain chain of method call in your code and to really understand which part of the chain we are referring to, caller versus callee, is a very important terminology to get clear about. But I'll talk about it first. And then error handling. Let's talk about the wrong way of doing it, which is by using console messages, system.out print line. Okay, I'm going to do some little demo to you today as well. And then what we're going to learn is the proper way in Java. And in all the OOP languages, they will have some kind of exception mechanism for you to use, which will be very similar to Java. And in Java, whenever you talk about how exceptions work, you just have to remember this term over here. It's called a catch or specified requirements. That's something maybe I wouldn't get to maybe today, but maybe Thursday. And we're going to use some example to show to you, and I'll do that most likely on Thursday from scratch. And then after that, we'll just revisit some example and put some more advanced usage for the exception handling. That's basically what we're going to do. We'll see how much we can achieve. But for now, let's get to the very important foundational concept about caller versus callee. Okay? And you can look at the slide as well. You also got some definition there, but consistent. So caller, think about caller is like a client using something. Callee is like a supplier. It's supplying something for some client to use. Okay? So whenever I talk about caller, it's really using the service provided by another method, the caller. I'm calling some method so I can use their service. Callee is I am the provider of this particular kind of service. If somebody else wants to use it, they got to call me. So I'll be the callee. Okay? And let's look at the simplest example here. We got some class C1, and then inside C1, we got a method called M1. Okay? And then we're creating a C2 object, assuming that C2 is somewhere, assuming that. I'm creating C2 object here, and then I'm calling C2 object.M2. Simple code. For those of you who might be a little bit lost already, why don't you take a look at this one here for 20 seconds, right? See exactly how we're using this method call here, right? This is where we're going to understand caller versus callee. And think to yourself this question here. Who is using the service of who? That's a question to ask. Okay? Let's now take a look. I'm going to annotate, and we're going to have some review question for you. Whenever you want to talk about caller or callee, we're going to make the context very clear about not just which method, but also which class you're talking about. Because sometimes method may have the same name. Right? So think about C1, M1 over here, this pair. This is the caller. Okay? Versus, you can see the O here was declared to be C2. And we're calling M2 from C2. Something like that. Okay? C2, M2, this is the callee. Okay, I'll write it down. The caller, C1, this is a little bit informal context notation, right? So when I say C1.M1, don't get me wrong. M1 is not really static, right? I'm just using it as a notation. The caller C1M1 is using the service provided by C2.M2. All right? So here, think about this one here is the caller. Oh, sorry, let me be consistent. C1M1, C1M1, and also C2M2, C2M2. And one thing to be sure that you know, how do I know? When I call this particular method M2, how do I know it's actually C2? It's because the context object over here, O, is declared to be of type C2. That's how I know. All right? O here is declared of type C2. Any question about caller versus callee? Pretty straightforward, huh? Now, the question for you to think about right away. Can a method, for example, C1M1 or C2M2, either one, can a method be a caller and callee at the same time? Is it possible? Okay, the answer is yes, it is possible. I'm going to give you one example here. There should be at least another example which you can think about. That will be exercise for you. Okay? The answer is yes, and this happens so often in code. Yes. Okay, let's see a 1. You can see here, C1 M1 here is already a caller. Why don't we make it a callee? How can we make it a callee as well? That means we want to somehow have another context which is going to use the service of M1. So we can make it a callee, right? We just need another caller who is going to call the service provided by C1 M1. That's how we're going to do. Okay? So option number 1. We can make C1.M1 a callee as well. Okay, let me sketch that. Let's say we got another class. Let's call that B, right? Or C3. Let's say we got another class over here. Let's say class C3. All right, let's say under C3, we got a method here, void M3. Inside this method here, we're going to create C1 objects. C1, let's say objects equals new C1. And then from this O here, which is declared to be C1, we can call this M1. O dot M1. Right, so now you can see for this particular part here, C1 and then M1 is a callee. C1 dot M1 is now a callee. Right, you can see we have one context where C1 M1 is a caller. We got another context where C1 M1 is a callee. So it's definitely possible. So whenever we talk about caller or callee, the context is very important. Right? That's the first point you want to notice. And I will give you one exercise to try out. Second, which will be exercise. You can see over here, C2.M2 is what we said a callee. Can you make it a caller? Oh, how do you do that? Exercise. Make C2 M2 a caller. That will be exercise for you. Question? Yes. Good. So basically, whenever we talk about caller callee, we'll talk about a single method call. We don't talk about multiple method call in the same piece of code. So here, when we think about here, we say only for this particular method call, O.M2, for this particular one. For this particular one, C2 M2 is being called, so it's a callee. And it's being called in the context of C1.M1, so that's why it's a caller, only for this one here. You might just have another method call in the next line. That'll be another story that we're going to discuss separately. So every time we talk about caller or callee, we're focusing on just one line of method call only. You're saying, okay, C1 here, we got M1 already. You want to have another method? Let's say M2. So what do you want to do for M2? M2 is calling M1. Okay, sure, that's okay. M2 is calling M1. Again, as I said, whenever you want to talk about caller or callee, right, focus on a single line of method call. Now, do you want to talk about this one specifically? Let's say, if you talk about this one specifically, now we are calling M1, so M1 is being called. So M1 should be the callee. Okay? M2 is calling M1, so M2 should be the caller. Can I answer your question? Okay, let me write it down. Good question. So your class may basically ask this one here. Let's say for C1 here, let's introduce another method. Let's say void M2. And inside over there, we're just going to say, for example, you can say this dot M1. Let's see, okay? When you analyze this particular line here, the M1 will be the Callee. So M1 over here. So C1, M1 is the Callee. At the same time, this will be the caller. C1 dot M2 is the caller. Right? The same principle is going to be applied, even though the context might be the same class, which is okay. Okay? Good question. I like it. Here and here. All right, let's now move on. Caller, callee, that's something we said. And this will be, okay, so I think that this will be a nice way to possibly end the lecture. So we got about 6 minutes. I think doing one thing here should be good. So there is something called call stack. And the term stack is going to be learned very thoroughly when you guys go to maybe the sequel to this course, 2101, data structure. But for this course, you don't really need to study everything about stack. I'll give you just enough for you to know. But in order to understand exceptions, you have to understand about method call. To really understand about method call, you have to understand call stack, which is intuitive. But let's see. And this is usually how you draw a call stack. When you put things into it, you're just going to stack on top, one by one. When you want to remove things, remove from the top, one by one. That's a very quick sketch about how things are going to go for a call stack. And let's now trace this particular conceptual example here, which is going to help you understand how method call is going to work. And then next time on Thursday, I'm going to give you some more concrete example. Okay? Let's say this. Let's say we got 3 different contexts. You can think about maybe 3 different classes. That's okay. But let's forget about class name just for now. Let's say we got method 1, method 2, method 3, right? Method 1 method 1 got some lines of code and then call method 2. And method 2 in turns got some lines of code execution and then call method 3. Method 3 got some lines of code execution and then without any more method call. Now we want to see exactly how these things are being traced and executed. All right? So I'm now going to number each line to see the sequence of execution. Okay, let's do it at one go. So let's say now we assume M1 over here will be the entry point of execution. So this M1 will be the first method to execute. So we're going to we start push. For stack, we say push and pop. And push is really like add something to it. Pop is like remove something to it. And for this course, I might just use the proper term push and pop, but informally, if you say add and remove, that's okay. We wouldn't be so strict on this course about stack. Right, now I can push M1 because M1 is now being executed. Only after M1 has been executed completely for all its lines will we actually pop it from the stack. Let's now see the sequence over here. This will be number 1, right? Executed. That's the first line. And then when we execute line number 2, this will execute M2. We will only get to the next line after M2 has been executed completely. So not yet. And we know there's a method called M2 over here, so we're going to push M2 onto the stack. So what does it really mean right now? That means the very first method was M1 that we wanted to execute. On its halfway through, we want to execute M2 first before we can remove M1. Okay? Now, let's now see what will be number 3. Now we're going to go to M2, right? So these ones will be for later. So number 3 over here, number 4 over here, number 5. Before we can get, where should be number 6? Should we actually go to here or should we go to here? Here, right? Because we got some method call. And we should do 2 things. Number 1, we should really say M3, so now should be push onto the stack. So we're going to get number 5 here. 6, 7, 8, 9, and 10. No further method call. After executing number 10 here, M3 is completely done. If M3 is completely done, what we're going to do is we're going to pop it out, remove it from the stack. And then right now, we set the top of the stack is M2. What does that mean? That means we should resume the execution for M2. Where should we resume? Here. All right, so now it should be 11 and then 12. After number 12, execution for M2 is also done. We should remove it from the stack. And then the only method that's left in M1 is, in the stack will be M1. That means we should resume it. So now 12 and then 13, 14, 15, we're done. And then pop it off from the stack. Now the stack empty. That means everything's done. Quick recap. Try to redo this example over here to see how the stack can be grown, also shrunk by pushing and popping, as I described. And then really understand how this particular sequence of execution is really being happening, like what I described. It's going to help you a lot when we dive into the actual code on Thursday. If you don't mind, I'll let you go earlier today. All right, thank you so much. I'll see you tomorrow in the scheduled lab session.